Okay, we're going to look at what happens when we make all of the perpendicular bisectors on a triangle. So in order to do this, I'm going to use my construction tools, and this is what you're going to be doing also. So we need our compass, and we'll need a straight edge. So remember, perpendicular bisectors are one of the first constructions that we learned how to do. And so basically we're going to do that to each side of our triangle. And we're going to look at what happens when we have all three of these perpendicular bisectors on our triangle. Because we already know that if we have one point on a perpendicular bisector, it's equidistant from the endpoints of the segment. So we want to see what happens when we have all three of them on there and what happens. So first I'm going to start by perpendicular bisecting this side. So remember, I have to open my compass so that it's more than halfway. Okay, and I'm going to make two circles, one from this end point and one from the other end point. Okay, if I connect those, with my ruler, okay, there's one perpendicular bisector. So I'll keep the bisectors red and I'll make the circles blue. So I've done this side, now I'm going to do the next side. So I'll do the bottom side here. Okay, I don't need it quite so big. Okay, just more than half, so let's go there. There's a circle from there. Make the same circle from the other side. Okay, I'm going to connect those. Okay, so right now I've got those two crossing. And I just need to make one more. So I need to perpendicular bisect this last side. So more than half, I might need a little bit more. Okay, make one circle there. Come over and make the last circle. Okay, make sure you try to keep track of the right ones. So where these two cross, I'm going to connect with my ruler. So just about there. Okay, now my construction's not perfect because these should all meet right in the same spot. So just about here should be the circumcenter. So let's kind of make a little bit bigger point where they all kind of meet. Kind of there, okay? This is called the circumcenter. And what's special about this point is it's on all three of the perpendicular bisectors. So I'm going to use a different colored line here. We'll do green and we'll make it dotted. All right, so if I measure the distance, so it's on this first perpendicular bisector. Okay, this first one right here, which means it's equidistant from these two endpoints. So it's equidistant from A and B. So that means if I connect the circumcenter to B and connect the circumcenter to A, Okay, these two green segments, green dotted lines, are the same distance because circumcenter's on the perpendicular bisector and every point on there is equidistant from the endpoints of the segment. Well, it's also on the perpendicular bisector of BC, so that means it's equidistant from B and C. So that means this segment is the same length as the other two green segments. So that's what's special about the circumcenter is it's going to be the same distance from all three vertices. And that's what you want to remember about the circumcenter. So the other construction we've learned about is the angle bisector. So we're going to create all the angle bisectors, and they're all going to meet in the same place, and that point is going to be called the incenter. We'll see if maybe I can get it to all be the same point this time. So if you remember the construction for an angle bisector, we're going to start by making a circle at our angle. So I'm just going to do that to all three angles first. Let's see. Okay, now from these points that we made on each angle, I want to make more circles. I'm going to make them kind of big so they're farther away. That one, I'll make the same one from this point. Okay, and I can just keep going. So this one and this one. Which is not the best. Let's maybe make it a little smaller. There, now we can see the intersection a little bit better. So let's see. So if we connect our vertex to the intersection of these lines, that's going to be our angle bisector. I think that's about it. Same thing here if I connect this vertex where these intersected. I'm right about there. We'll make one more. This circle's going to be too small, so I'm just going to make one that's a little bit bigger. And use those as my points. Okay, so these are constructions we've done before. Okay, we use this to make parallel lines. Or no, that was copy and angle. But we did this in the first chapter. Make my last angle bisector here. Through that point. And I'm pretty close. Okay, so they're all going to meet right there. Let's change the color of our angle bisectors here. Okay, so where these angle bisectors meet, that's called the incenter. Okay, and now if you remember, every point on an angle bisector is equidistant from the two sides of the angle. So this point should be the same distance from this side as it is from this side. In order to make the distance from a point to a line, we need the perpendicular segment that connects those. So I'm going to need to make perpendicular segments. So I'm going to get rid of some of these blue lines here. Just so we can see a little better. Get rid of these circles too. Alright, so this point, I want to be perpendicular to this line and go through that point. So that's another construction that we had. So first thing I'm going to do is go from that point, I'm going to make an arc that's going to touch two spots on my line. Now if you notice, it's not really touching this other spot on my line. I need to extend this side so that it comes into contact with my circle over there. Okay, and then I'm going to bisect that. So I'm going to do my bisector now, and it should go right through that point. Okay, so when I make this will be my new segment here. Okay, so really I just need it to be perpendicular. So it'd go through here, and the distance from here to here is going to be the same as the distance from here to any other side of the triangle. So the special property of an incenter is it's equidistant from all three sides of the triangle. So circumcenter is equidistant from the three vertices of a triangle. Incenter is equidistant from the three sides of the triangle. So I'll make one more here just to demonstrate the construction for that again, for that perpendicular segment. So I need a circle that's going to touch 2 points there. And then I bisect that segment. Okay, so here would be another segment that connects perpendicularly. Okay, and so the distance, okay, from here, okay, these two segments would be the same. Okay, and then the last one would be perpendicular to this side. Should be over here somewhere. Okay, and that'd be the same length. So you get these three sides that are the same length.